Good morning, afternoon, evening, whenever you happen to watch this, everybody. Welcome to the Homework Helper 4, section 2.7. We are going to be doing a couple tasks today. The first one in our ready is we're going to be evaluating functions and creating tables of values. This shouldn't be too difficult, but our goal here isn't just in filling in the blanks, but it's in trying to make the connection between what is happening. So for example, this very first one, we have f of x equals 3x plus 5. This is just a linear equation that we've seen before. Then we have g of x, which is 3 times the quantity x minus 1 plus 5. So what I want you to notice before we even really get started on this thing is what the difference is. And the difference is that we have this minus 1 right here, right? That little minus 1 is the only thing that's changed. We put it in the parentheses and put a minus 1. So what do we think is going to happen because of that minus 1? How will these numbers be less? And I'll give you a second to think about that. Go ahead and pause the video. What do you think will happen? Okay, let's find out what actually happens. So let's go ahead and plug some numbers in. If we do negative 1, that's 3 times negative 1, which is negative 3. Negative 3 plus 5 becomes 2. All right, let's do it again. Let's plug in 0. 0 times 3 is 0, plus 5 is 5. 1 times 3 is 3, plus 5 is 8. And we see that we now have we can easily see our pattern. We see that our common difference is 3, and so each time we're going to go up by 3. Right? 3 times 3 is 9, plus 5 is 14. Cool. So let's do the same thing here and see how this minus 1 affects our sequence. So now we're going to put negative 1 in. Negative 1 minus 1 is negative 2. Negative 2 times 3 is negative 6. Negative 6 plus 5 is minus 1. 0 minus 1 is negative 1. Negative 1 times 3 is negative 3. Negative 3 plus 5 is 2. 1 minus 1 is 0. 0 times 3 is 0. Plus 5 is 5. And we can start to see our pattern emerge. 8 and then 11. Right? 3 minus 1 is 2. 2 times 3 is 6. Plus 5 is 11. So what we see here is look at the connection between our f of x and our g of x. That minus 1 did what to us? Well, it didn't subtract 1, but it subtracted by a factor of 3 because we do have that 3 times that minus 1. So that what we end up doing is we end up going back a sequence, right? Here when it's 0, it's 5, but here where it's 1, it's 5. Here where it's 1, it's 8. Here where it's 2, it's 8. So we're always back one sequence because of this shift. So it's interesting to see how that one change changes everything. Let's go ahead and do another one. I'll do number 5 and 6 here. So let's look at what happens here. So we're going to raise 2 to the negative 1 power. So that's going to be 1/2 times 3, or 3/2. 2 to the 0 power by rule is 1. 1 times 3 is 3. 2 to the first power is 2 times 3 is 6. 2 squared is 4 times 3 is 12. And we start to see the pattern, and this, of course, is our common ratio. So 3, 8, 24. So each time we are doubling. Okay, we double, 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 double. So now we have x to the minus 1. So what do you think is going to happen? I'm going to take a guess. I think it's going to behave very similarly to problems 1 and 2 up here, and we're going to go backwards a step. So let's go ahead and find out if that's true. So negative 1 minus 1 is negative 2. 2 to the negative 2 power is 1 over, right, 2 to the negative 2 is 1 over 2 squared. So that's going to be 1 over 4 times 3, so 3/4. 0 minus 1 is negative 1. 2 to the negative 1 is 1/2. So that's going to be 3/2. 1 minus 1 is 0. Anything to the 0 power by rule is 1, so this is 3. 2 minus 1 is 1. 2 to the first power is 2. This is 6, and we see our pattern. And sure enough, that minus 1 behaved exactly the same, where this became that, etc., etc. So we end up going back a step in our sequence. So that's how those ones are going to work. Now, when you look at these ones over here, we see that both are being changed. This is going back 2. This is going up 1. Right? So that's minus 2 to 1 is a difference of 3. So I would bet if I were to make an assumption that we're going to go like three off, right? It's going to be 3 off in some way. So keep that in mind as you look at these. Let's go ahead and go to the next section. Oh, okay, find the next section. There it is. Okay. So for this, it wants us to transform our radical form into our exponential form and vice versa. It's just to make sure that we completely understand this. So this transformed would be 5. This remains our numerator. The root becomes our denominator. Here, 16, 4 becomes our root. 3 becomes our numerator. Or not our numerator. 3 is our numerator, so it becomes our power. Okay, now this one's different. It's got a multiple, so it's going to apply to both. So this is going to be, we're going to look at it like this, and then we're going to look at that one. So this becomes 5, 7 becomes our numerator over 3, times 3, 5 becomes our numerator over 3. Okay, so that's all we got to do for those. So yes, pretty self-explanatory. Some of them get a little crazy, but I believe in you. Finally, topic is x-intercepts and y-intercepts for linear and exponential functions. It wants us to find the intercept. So let's talk real briefly about what an intercept is. We know that this is a y-intercept. Anywhere that the line crosses the y-axis, this is our y-axis, this is our y-intercept. And then anywhere it crosses the x-axis, this is our x-intercept. Now, it's interesting to note, and important to note, that the y-intercept is where x equals 0 at our y-intercept, and our x-intercept is where y equals 0. So to figure out what our intercepts are, we can just plug these numbers in for x and y accordingly. So for example, to find my x-intercept, to find where it crosses here, I plug 0 in for y, which in this case is f of x. So 0 equals 5 times x minus 4 minus 10. So now I just solve for x. I add 10 to both sides. 10 equals 5 times x minus 4. Okay, I divide by 5 on both sides, giving me 2 equals x minus 4. I add 4 to both sides, giving me 6 equals x. So I know that when 6 equals x, 1, 2, 3, 4, 5, 6, this is my x-intercept. Now I do the same thing for the y-intercept. For that I plug 0 in. So I'm going to have y equals 5 times 0 minus 4 minus 10. This is going to be minus 4, so this is y equals negative 20 minus 10. This is going to be negative 30. Y equals negative 30. So I'm going to have to scale my graph a little bit. When I scale my graph, let's just say each of these is 10. So 10, 20, 30, 40. Negative 10, negative 20, negative 30, negative 40, and this is negative 30, so it's going to cross right there. So that's what my line will look like. Okay. But because this number was so big, I had to scale my graph. Don't forget to scale your graphs. All right, people. That is going to do it for today. You can do, well, actually, you know what? Let me do this one real fast. Let me do the one with the exponent, just so that we're as clear as possible. So let's start by finding our x-intercept by plugging 0 in for y, which in this case is g of x. So 0 equals 5 times 2 to the x minus 1 power. Divide by 5. So 0 equals 2 to the x minus 1 power. So what number can make that 0? The answer is that the number doesn't exist. There is no number that will cause this to be 0, right? Because even if x is 0, it becomes negative, it becomes 1 by rule, right? So if this is 1, when x is 1 minus 1 is 0, that becomes 1 by rule. We can never get this raised to a power to equal 0. It's simply impossible. So this is actually an asymptote. So we know that we're going to have an asymptote at x equals, or at 0, at y equals 0. So we got to go which is pretty cool. We know that at least. Okay. So there is none. There is no x-intercept. No intercept. Okay, and then our y-intercept is where x is 0. So y equals 5 times 2, 0 minus 1 equals 5 times 1/2 equals 5/2, which is roughly 2.5. Actually, it's exactly 2.5. So we know it crosses at 1, 2.5. And so, sure enough, this being exponential, we know it's going to look something like this. It's going to curve up, and then it's going to curve down, and then it's going to approach 0, but never, ever, ever touch it. So that one's kind of neat. So be mindful of that we do end up with asymptotes when we have these exponential relationships. All right, now that is enough for today. Good luck on your homework, and see you next time.